So hello guys, in today's video we'll be doing the level order traversal on a binary tree. Okay, basically we're gonna do breadth first search. Let me tell you one thing guys, in trees when we do breadth first search and when we do depth first search. For depth first search we have two ways. One is use recursion, second is using stacks. In this we use queues. Oh, so I'm so sorry guys, just ignore. Yeah, we use queue. Okay, now coming on to the question or basically the implementation of the level by level order traversal. First I'll tell you what is it. First of all, yeah, level order traversal is basically traversing from wait, let me change the color. Yeah, level order traversal basically traversing from 1, 2, 3, then 4, 5, 6 and 7. Okay, like we go from 1, then 2, then 3, then 4, then 5, then 6, then 7. Okay, and we use a queue for it. And how we'll do is we'll make a queue. First we'll put 1 in it. Then we'll check if our node has left or right. If it has, we'll do left and right and we'll put this, and we'll cancel, we'll just take out the 1 and we'll append it here. Now in the other queue, now on the second level, now it is the second level, it was the first level. Now on the second level, when we'll go, first we'll check if 2 has left or right, and yeah, it has. So we'll just append this in queue 4, 5. Then we'll cancel out the 2 and we'll put 2 here. Now also in the same level we see if there is 3, yeah, there is 3, and this 3 has left and right, and yeah, it does have 6 and 7. Okay, so we'll cancel out 3 and we'll put here. Now we don't have anything in this level. Now we go to the next level. Now guys, you're saying one thing, we are going to the next level only when in this level, in this size, there is nothing. So do you getting an idea? Like we'll use the length of the queue, we'll use the length of the size, and we'll iterate in the length in the level, and we'll check node dot left and node dot right, and if they are, we'll append it to that, and we'll just use a for loop till the length of the level of the size, and this level of the size is basically the size of the queue. Okay, don't worry if it is not clear, I'll clear it in the code. Now what we'll do, we don't have left dot right, we don't have any child to this level, so we'll just paste it here, 4, 5, 6 and 7, and this is the answer guys. That's it, that is what we have to do. Now we'll implement in it is basically the question binary tree, the level order traversal 102. So we'll implement here. Okay, so yeah, first let's start. Yeah, this was this is what I was talking about. Level underscore size is basically the length of the queue, and we'll make an empty list of level. We'll append, and now we'll use a for loop just to append all the elements in one level. Like first I put in the first level, I already put this one, and then I'll append this and go to the next level and then append this. I'll just show you how this is working in the code. Okay, now for underscore in range level underscore size. Now we'll we just pop out the node from the queue which was already given, and the first root, the root node which was put into the queue, we have popped that out, and now we'll append that level dot append level dot append node. That's it. And now we'll check if we'll append the values, guys, here. Yeah, just make sure we are appending the value of the node. Now if node dot left, if node dot left, then we'll just add the left node into the queue, right? Queue dot append for the next iteration. We'll append this in the result. What we'll append in the result is the levels, and we'll return. Okay, make sure. Yeah, yes, it's working fine. Now I'll explain you few things here, guys. First of all, what we did, I'll explain each and everything line by line. If not root is basically if there is nothing, if there is no root, then we return an empty list, just like this. There is no root, we're returning an empty list. Okay, now we from collection import dq. I am doing this in Python, so we import the dq, and dq allows us to have several more operations, like we can pop from left as well as right. And I hope you know what how does queue works. Queue works on the principle of first in first out, that is FIFO, and stack on LIFO. Okay, I hope that you already know the basics of this. Now what we have done is we have taken a list that is a result, an empty list, basically this, the output list. We have taken this. Okay, now this is empty. Now in this, what we have to append is basically all the elements in all the levels. Like in first level there was 3, second level 9, 20, third level 15, 7. Okay, so this is the this list output from here to here. Okay, now we already put in our queue, we already put root. We already put root. Now why did I do that? What I'm saying is, in the queue, which is first in first out, I already put 1 here. Why? Because because the length, because I have to do this, because if I'm starting from the root of the tree, the first element, that is guaranteed that it will have a length of 1, right? It will have, in fact, it will have length of 1, because only because there will be a root. That's it. Because this guy, this guy, this guy will be there on the first, even if it is a tree of 10,000, 100 million of 10 to the power 6 operations are there, but still the first guy will always have 1, second guy have 2, then the other guys might have the other guys, like the first guy it's 2, then it's 1, 2, 3, 4. Basically, it's 2 to the power 0, then 2 to the power 1, then 2 to the power 2, then 2 to the power 3. Okay, so the first guy will have the length of 1. So I took the length, then level. Now I have to travel in level. Why I took level underscore size and why I took this length is basically that at every level I'll put a for loop. Every level I'll put a for loop, and in this it will go from 2. The for loop iteration is 2. Basically the length of the queue, that is 1 and 2, and I'll append this guy and this guy. In this, length is 2 to the power 4. 1, 2, 3, 4. In the other way, what will be the length of the for loop? It will be 2 to the power 3. There will be our for loop will iterate from 2 to the power 3. Basically, will iterate 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now coming on to the next thing, which is I'll pop. Will just pop this thing. I have put that into the queue. I'll pop it and I'll paste it. I'll return it, append it in a result. I popped it and I appended into the result. Okay. I made a variable node, and this I made a variable and I popped it and I appended it in that. Now also after appending, I also took care, guys, one more thing, when you're appending, just don't forget you're appending the value, you're not appending the node, okay? Otherwise, if I append the value, if I forgot, what will happen? It will give you a error, a runtime error, okay? So make sure you append here the node, the value of the node, okay? Now coming on to the condition, now we popped the node and we appended it in that. Now we'll also check, does this guy, wait a sec, we'll also check, does this guy has a child, has something on left, does it have? Okay, and it has, then in the queue which is empty right now, append that. We append 2 here. Now also we check the right element. Right element is 3. Does this guy have a child on the right side? It has. Then append that into the queue. Now the level of, now we appended into the queue and our queue was empty basically. Now we appended the child left and right, and what is the length of this? It's 2. So our for loop, basically our for loop will iterate 2 times basically, because we are iterating from the length of the queue, okay? And then we'll go again into the while loop, again into the for loop. We'll do node queue pop left. Now we popped 2, okay? We popped 2. Now we'll check that, basically like this, you can see we popped 2, we appended the value. Now we'll also check, does 2 has some child? Does it have? It has. It has 4 and 5. So in queue we'll also append 4 and 5, and now our iteration, the for loop goes on, we append. Now here in the next iteration we append this thing, and this is 3. Now we check, does 3 has a child left and right? It has. Then put it into the queue. We put 6 and we put 7, and we calculate the length of the queue. What is the length of the queue? Length of the queue is 4, and we do the following 4 operation. Now this time we don't have the child, so we won't look for any child. We'll just append this 4, 5, 6, 7 in the traversal. And guys, if there is a next level, what will it be? What will it be? This. Basically we'll iterate 8 times. Why? Because 4 has some child, okay? Then 5, then 6, then 7. So it how much? 1, 2, 3, 4, 5, 6, 7, 8. I hope it is very clear, crystal and clear. If you still have doubts, just tell me and I'll try to clear. But I hope it's clear now. So thank you guys. Thank you for your time, and I hope you learn.